This is college algebra. This is section 6.1. This is going to be part 2 of the notes. Last time we talked about solving equations and how to manipulate equations, for example, changing Fahrenheit into Celsius. Now we want to talk about the graphing side of linear equations. The x-intercept of the graph of a linear equation is the point where the graph crosses the x-axis. The y-intercept is the point where the graph crosses the y-axis. So if we take a look at this line down here, the x-intercept is given by this point right here. Let's call it 2, 0. And the y-intercept, where it crosses the y-axis, is the point 0, -1. So here's an example. Graph the equation 3x plus 5y equals 20 using x and y intercepts. In order to solve for the x-intercept, we have to let y equal 0. And if we do that, then I have an equation 3x plus 5 times 0 equals 20. 5 times 0 is just 0. That leaves us with 3x equals 20. Divide by 3, and you get x is equal to 20 divided by 3, which is about 6.67. That point is going to be actually just off the line here, so that's going to be our point. For the y-intercept, you always want to let the other variable be 0, so let x equal 0, and therefore that gives us an equation of 3 times 0 plus 5y equals 20. 5y equals 20, divide by 5, and y is equal to 4. That's a nice rounded number, so the y-intercept is going to be 0, 4. There is our line. Another example, graph the equation 4x plus 3y equals 18 using x and y intercepts. At this point, please pause the video, give this problem a shot, and see if you can do it on your own. All right, here we go. So for the x-intercept, we're going to let y be 0. Divide by 4, and we get a fraction. X equals 18 fourths. That's going to be the same as 9 halves, which is 4.5. 4.5, we're going to go 1, 2, 3, 4, and about halfway. For the y-intercept, let's let x be 0. 3y equals 18. Divide by 3 on both sides. Y is equal to 6. So this intercept is going to be 0, 6. There you are. Not too bad. Let's bring in linear models and graphing into a word problem. So suppose that you have saved $4,810 to use for living expenses at college. You expect living expenses to cost $580 per month. There are two variables we have to identify here. The first is the budget, or how much money you have left. And the second is the number of months you spend at college. So our budget at any given time is going to be $4,810 minus $580 for every month M that we are staying at college. That's our equation. In order to graph it, we have to come up with our own units. So $4,810 is a pretty big number. So how about I start at 0 and I go by 1,000s? And on the bottom, so this is going to be B for budget, That's actually our y-axis. Along the horizontal, we'll put months. And we can label those with single digits. Now, the y-intercept will occur at 0 months. So that would just be $4,810. That's where we start. 0, 48, 10. Every month we're going to spend $580. So after 1 month, we got to go down about 580. So it's approximately there, a little bit lower. And then 580 again, a little bit lower, and so on. A little bit lower. So it looks like our straight line budget gets us to just over 8 months. How would I solve that algebraically? Well, what we have to do is just let our budget be $0 and solve. I'm going to subtract 4,810 from both sides. And then divide by negative 580. We get an answer that should be just over 8 months. 8.29 months. Let's keep going. Same idea. Pause the video and see if you can graph the equation and interpret the meaning of the intercepts. All right, here we are. Now, our budget begins at 6,500, which is going to be just above the graph here because I still went by 1,000. And I'm going to go down $425 each month. So we'll go down a little bit. It's still going to have this linear look to it, all right? But where does that intercept hit? Again, we'd have to let our budget be 0 and solve. Divide by negative 425. A negative over a negative is a positive, so m should be positive. $15.29 months. So even though the way I set up my graph doesn't show the x-intercept, I can still interpret that algebraically and say we have about 15 months worth of living expenses. Now, if x1, y1 and x2, y2 are 2 points on a line, and they are not equal, they're distinct points, then the slope of the line is defined by m equals the change in y divided by the change in x, which is also known as rise over run. Delta y divided by delta x. Delta just means change in this case. So find the slope of the line containing the points 1, negative 2, and negative 6, 18. Let's label our points and use the formula for slope. M equals 18 minus negative 2. Whenever you plug in a negative number, be sure you use parentheses. Negative 6 minus 1. So we have a double negative here that's going to become a plus, and that's going to give us 20 over negative 7. Next, find the slope of the line containing the points 12, -9, and 0, -6. We're going to do -6 minus -9 divided by 0 minus 12. So 6 plus -6 plus 9, that's going to be +3 over -12. Be sure to reduce your fraction. Divide by 3 on the top and bottom to reduce it, and we get 1 over -4, so -1/4. 5 minus -21 divided by -7 minus 15. So that's going to turn into +21, which is 26, divided by -7 minus another 15 is going to be -22. Let's reduce again. Divide by 2, and we're going to get -13 over 11. A linear equation is now in slope-intercept form if it is written in the form y equals mx plus b, where m is the slope and the point 0, b is the y-intercept. We can now write equations with simply a slope and a y-intercept. In order to change standard form into sloped-intercept form, we are going to solve for y. So let's subtract 4x from both sides. They don't go together because one has an x and the other does not. And then divide by 3 everywhere. Y equals, I'm going to stick with the convention and put this one first, and I'm going to write -4/3 x plus 5. So all I did was switch the order there. Okay, example. Suppose you are considering renting a car from 2 rental companies. Enterprise charge you a base fee of $50 plus $15 per day. So we'll write the cost of Enterprise, that's a little subscript, is $50 plus $15 per day. The cost of Hertz is $70 plus $12 per day. So I already wrote 2 equations to model the situation. After how many days does Hertz become the better purchase? We're going to skip the graph for now. And we can set these costs equal to each other in order to find when Hertz becomes a better buy. So 50 plus 15d equals 70 plus 12d, and solve. Subtract 50 from both sides. $15d equals 20 plus 12d minus 12. So 3d equals 20 divided by 3. D equals 20/3. And so 20 divided by 3 is 6.67. Now, you would have to have the car for 6.67 days in order to make Hertz the better buy. But read through the question. It says how many days. So we would actually have to round this up to the nearest day, and the answer would be 7 days. Example 8. You can rent DVDs at a local store for $4 each. Think of like Redbox. The other option would be Netflix offers a flat fee of $15 per month. Write and graph two equations to model the situation. How many DVDs do you need to rent to make Netflix the better purchase? At this point, once again, I'm going to ask that you pause the video, write two equations, graph them, and solve. All right, here we go. The first cost for, say, rental DVDs would be $4 per DVD. So I'll put D there. There is no upfront cost. Compare that with renting a car where you have to start by paying a base fee. You do not have to do that here. So then the cost of Netflix is actually not dependent upon the number of movies or DVDs you watch. It's just a flat fee of $15. This is actually going to be just 15. Now what that means is that's going to be a straight horizontal line. There is no slope. It's like saying plus 0x. There's no slope. Let's come up with a graph for this. Let's put cost along the y and number of DVDs or movies along x. 0, 1, 2, 3, 4, 5, 6, 7, 8. The cost is in dollars, so why don't we go by $2, let's say. 2, 4, 6, 8, 10, 12, 14, 16. The reason I went by 2 is because it costs $15 as a flat rate, so that's going to be the line that I want to draw. $15 as a flat rate is going to be a straight line. So that's Netflix. On the other hand, to graph this one right here, well, if you rent 0 DVDs, then you would pay $0. If you rent 1 DVD, you pay $4. If you rent 2, you pay $8, and it goes up by $4 each time. If you've drawn a really nice graph, you can tell how many DVDs you need to rent to make Netflix a better purchase. It looks like you would have to rent 4 DVDs or watch 4 movies to make Netflix better. But let's do it algebraically by setting these two equations equal. 4D equals 15 divided by 4. So the number of DVDs would have to be 3.75. And you have to round that up, and that would have to be 4 movies. There you have it. Please comment on this video in order to earn credit, and then have a nice day.